What's up, Config 2023? What's up? I'm just so excited to have you all here. Like so many of you, this is my first in-person config, and the vibes are good. And thank you so much for everyone on the live stream as well. I'm Rachel, and I'll be your host on this stage for the rest of today. In my day manager, I'm an engineering manager here at Figma, working on our design editor. As you can imagine, we've been working quite hard on some new features that we were really excited to share with you today. The team I support just released the new font picker and the new auto layout, and we're really excited for y'all to play with them. Thank you, thank you. Fun fact, this is our 5th major release of auto layout, so we've been affectionately calling it V5. If you all have any hopes, dreams, inspiration, ideas for V6, just let us know. Well, we are halfway through day 1, a ton of great talks left. For this next session, we have Amjad Masad, the CEO of Replit, to share how they're using AI to empower the next billion creators. In today's world, developers play a key part in shaping the digital landscape. Empowering developers is an important part of making sure as many voices as possible are a part of that conversation. We're fortunate to have such a visionary leader who's revolutionizing how software development happens with us here today. And so with that, let's give a welcome to Amjad.
Thank you. All right. Well, thank you, Rachel, and the rest of the Figma team for having me here. Excited to be here. Been following the Figma journey for many years. First time I met Dylan and team in 2018, and I couldn't imagine them kind of booking an entire huge conference like this and really putting together a great event with the most stylish people I've ever seen in tech, which is pretty amazing. So let's see. So today I'm going to talk about Replit and how we're using AI, and also hopefully trying to kind of tell you about our journey and how we build with LLMs and ideally kind of leave you with some tips and some ideas on how to start thinking about building products with AI and LLMs. So if you're not familiar with Replit, Replit is fundamentally about reducing the friction between having an idea and having a software in the world. So we want to take people from just sort of any idea, startup idea, project, an art project, any kind of thing that could be materialized as software, and reduce that friction, hopefully down to zero over time, to get a sort of a software project in the world. Many people are familiar with Figma here. So Replit is sort of like Figma in that it's collaborative, it's in the browser, it's multiplayer by default. You can share a link, and anyone can run your software, try it, comment on it, play with it, or help you develop it. All right. So if we're able to actually solve this problem of getting from an idea to a piece of software as easy as possible and as simple as possible, we think we're going to reach 1 billion software creators. And notice, we don't talk about just developers. Developers are a kind of software creator, but we think about all of you as designers, maybe some product managers, maybe people working in tech in other capacities. We're all software creators. And we believe that software creation is something that everyone fundamentally wants to engage in. And it's like a good thing that more and more people, if we can be more inclusive and allow more and more people to engage in the act of creating software. So when we started the company in 2016, kind of based on this open source project, that I had been working on for many, many years since I had the idea of just trying to make software more accessible. Even in 2016, it was obvious to us that in order to get to the point where software is truly fun to make and easy and accessible, that AI is going to play a big part in that. And so today I'm going to talk about why now, why AI is kind of exploding into the world, and sort of what implication this has on software particularly, and also our journey in kind of integrating LLMs into Replit, and sort of talk about some of the challenges and some of the opportunities about building with LLMs. And finally, I'm going to talk a little bit about the impact and what we're seeing from the wider community as we've sort of invested in this category. So why now? Well, first of all, I'm sure a lot of you have heard this term, large language models. It still kind of feels like ambiguous, and really everyone defines it a little differently. So I'm going to give you a definition that really stuck with me. But basically, large language models are computers programmable with English. They're a new type of machine that you can talk to, and it can do actions in the world with just English. It essentially has one function, which is predicting the next token. And so when you give it this English program that we call a prompt, what it's doing is trying to continue that prompt based on what it's learned from the massive internet data that it's seen. So it's machines programmable with English, which is kind of a wild thing to have in a world, that we finally got to a point where there's a machine that's programmable with natural language. Transformers are actually the underlying technology behind large language models. They're a type of machine learning model, and they were invented in 2017 at Google. And they're really good at just understanding relationships between large sequence of text. And of course, language is text, code is text, and many other things can be represented as a series of tokens. It wasn't until ChatGPT that sort of large language models were catapulted into the public consciousness. But actually, many of us have been building with them since 2019, since GPT-2. And even before that, they've been integrated into product you always use, such as Google Search. Google Search integrated a transformer model called BERT in 2019. Gmail has the autocomplete feature in Gmail was also powered by transformer models. Translation, such as Google Translate. So these models have been around for a long time. But it wasn't until OpenAI figured out that when you scale them up, when you make them bigger and you train them on more and more data, they become way more powerful. And also, crucially, especially for a room full of designers, is that it wasn't until they put it into this form factor, that is chat, that it really, really exploded into people's consciousness. And this is, I think, a huge lesson for how technology can go from something powerful yet inaccessible to something really, truly accessible that a lot of people could use. So in addition to sort of large language models being able to handle natural language, turns out they're really good at code. They're actually unreasonably good at code. And like one of the first major products that were built on top of large language models was GitHub Copilot, which is a coding assistant. So why is that? Why is something that's called large language model is actually good at code? So it's not really intuitively obvious that's going to be the case. Well, it turns out programming languages, just like natural language, they're actually sort of a sequence of text, but not only that, they're actually very repetitive. So the reason why statistical models, machine learning models, are able to model natural language very well is because a lot of what we say is sort of repeated, hundreds and thousands and even trillions of times. Well, it turns out a lot of programming that we do every day is sort of the same thing. I'm sure a lot of you have written sort of the same, HTML or Flexbox code for like the 1,000th times. Hopefully, Rachel's theme and auto layout will save us from CSS. But because of that repetition, coding or code is actually possible to model it in machine learning. But more importantly, programming languages are actually structured. They're supposed to be less ambiguous. They're supposed to be less degrees of freedom. That way, the grammar is more deterministic, and we're able to kind of make statements about code that we know are true, whereas in a lot of natural language, it's sort of really hard. There's like common sense, and the sort of grammar is often ambiguous, but with code, hopefully, unless you're using JavaScript, which is known for not being very deterministic. For example, if you leave semicolons are optional, but they totally change your program's meaning. Or null is an object, or not a number is a number. But anyways, most programming languages are structured and are ideally verifiable. So, just before I just sort of talk more about coding and LLMs, I just want to sort of share some data to show you that this is not theoretical, or this is not something that we're just like literally just starting with. It is actually happening on a massive scale. This is the number of projects using OpenAI on Replit, just hooking into OpenAI. So year over year since 22. We've seen a 3,000% growth in projects on Replit, people building AI projects. This doesn't count people who are using ChatGPT or Ghostwriter, our tool. This is just people interested in building AI projects, which is kind of amazing. So if this trends continue, this is really the next era of software. All right. So in addition to sort of code being possible to statistically model, it turns out that large language models perform better even on natural language tasks when they're trained on code. The open secret in the sort of machine learning world right now is that most major models, most consumer models, such as ChatGPT, are actually code models. It turns out that OpenAI's Codex was better at reasoning than GPT-3, the traditional GPT-3. And so most models today actually train on code first before they train on natural language. And this wasn't like sort of very intuitive for the machine learning community. Why is it that code models are actually better natural language models? This is a sort of an extract from a paper trying to explain why sort of models trained on code are actually very good at reasoning. And maybe you sort of could predict that, but like basically, if a model is trained on code, it can get better at planning. It can get better at kind of breaking down tasks. And this kind of shows, this diagram shows that you have something like a goal, like serve pies on a plate, and you can sort of model that goal as a series of actions in a tree. As LLMs kind of learn how to model code, they learn how to model trees, they learn how to model steps, they learn how to model graphs, they learn how to reason in more explicit manner. In addition to just making the LLM smarter, also code is incredibly valuable as an interface for large language models to interface with the rest of the world. You might have seen ChatGPT plugins. The way plugins work is by the ChatGPT model actually emitting code that could call into APIs and sort of other external functions. So just to summarize, code can be modeled just like natural language. LLMs, if trained on code, are actually better natural language reasoners. And third, LLMs can use code to interface with the larger world and kind of make actions on your behalf. Just to do make this more concrete, this is our Ghostwriter Autocomplete product. So in your Replit editor, as you're typing, the model is predicting what code you want to type. In this case, it's CSS. And based on the comments, based on your project files, based on you and a lot of other things that we prompted the code model with, it's able to predict the next line, the next function, the next piece of code. And again, this has been happening for many years now. Since 21, we started investing in LLM features. Obviously, GitHub Copilot is something that a lot of people use as well. And that was sort of the first obvious step to use code models in a practical way. But autocomplete is just the start. I think integrating LLMs and making products more delightful is going to be a lot more than just autocomplete. So we'll talk about our journey kind of designing with LLMs. First, to kind of step back a little bit and contextualize the moment we're in, one can think about this moment as another major shift in software. The last major shift in software that we've seen was mobile. So in 2007, sort of the world was upended, and everything we learned about how to make software had to change. Because now people are walking around, carrying around computers and small rectangle screens in their pockets, and it had capabilities such as GPS and other things that unlocked new types of applications. And we think this is another sort of mobile-like moment where software has to fundamentally change. When the App Store first came out, I think that the iPhone was 2008 or 2007, the App Store was 2009, the first apps were basically shrunk-down websites. Same buttons, same links, everything that we do on a website, we just shrunk it down and call it a day. It wasn't until 5 years later that the first truly native mobile apps started to appear. Tinder with its swiping functionality is an example of such an app. And if you remember at the time, 2012, 2013, every year there's like a new app, or every few months there's a new app that really uses the iOS platform in a native way that really feels great for the medium. So what is the, in 4 or 5 years' time, what is the actual sort of form factor that software will take given AI? Right? I mean, the obvious thing is chat, right? I mean, we're all used to chat, but it's not the obvious is not always the most optimal. For us, we also started with chat. Ghostwriter, again, our code model. You can open it in a chat window just right next to your code. You can ask a question about your code, summarize my code, teach me something about it, debug it, complete it, do all these things, and it's just basically a chat box right next to your editor. But there's a lot of limitations in this. First of all, it's not very ergonomic. You sort of like have this context switch. You're looking at code, and then you're looking at this chat window. And we're sort of used to that context switch, and we, because we're used to that in chat and Slack, you have your editor somewhere, and then maybe you're talking to your coworker somewhere else. But that's not really a coworker. It's still a piece of software, and we can build it and sort of mold it in ways that make it more functional, more usable. So what about talking about code in line? So this is something we're starting to do, is that just to go away from this pure sort of chat modality and starting to make it possible for you to interact with the AI right in context. And this is a lot better because it also allows the user to discover the kind of functionality that are possible. One of the hardest things about chat models or chat sort of UX is that it is unclear to the user what they can do with it. They sometimes overshoot their expectations. I'm sure a lot of you kind of asked ChatGPT to make a phone call, and maybe it hallucinated something and told you I made a phone call and no one answered or something like that. We've seen all these screenshots on the internet. That's because the model doesn't know what it can do, and it will just give you sort of a BS answer, and you don't know what to do with it. So we think like a better way is to sort of contextualize these features right into your UI. This is another example where we've asked the model to do something on our code, and it sort of on the fly generated sort of a GitHub pull request view where sort of like view where it's actually diffing the code. It's showing you what it's about to do to the code, and you can ask it follow-up questions, or you can accept its suggestions. Another sort of big design challenge that we face is the concept of latency. These models generally run on a GPU somewhere in a compute cluster somewhere. And it's really hard to predict when they're going to stop. Sometimes they want to kind of complete the entire function. Sometimes they want to complete a single line. You can add all sorts of heuristics to actually know how long they're going to need to complete the thing. You can add streaming. There's all sorts of hacks you can add. But ultimately, latency is a challenge for designers. In a situation where the use case is more passive, such as completing code, you want the user to actually not have to kind of ask the model explicitly for an answer, but the model has to push this answer in front of the user when it has a better answer. However, at the same time, we have classical tools, such as classical autocomplete. Some people call it IntelliSense, so other people call it LSP or language server protocol. But basically, you see two of these patterns here that are totally different. One is a sort of a classical pattern, meaning it uses classical algorithms such as parsing and tree search to generate sort of the suggestion. And then you have something that's perhaps more powerful, perhaps more error-prone because it's stochastic, it's statistical, but that's in the background, that's the ghost text, as we call it. And we try as much as possible to be able for these patterns to coexist. So in this case, if you hit enter, you actually accept the classical suggestion. If you hit tab, you accept the statistical suggestion. Another frame on this to think about this is imperative versus declarative. So declarative is about saying what you want and for what you want to happen. Imperative is about you doing these things step by step, going through and clicking and dragging things around to produce the desired output. In this case, products like Figma or Photoshop or whatever are largely imperative. New products that you can interact with primarily via prompts, such as Runway, where you can produce videos and edit them, those are more declarative. You say what you want and something happens. They have different trade-offs, and I think instead of thinking about it as sort of this binary thing, your product's either declarative or imperative, we think we can merge these worlds and have them interact in sort of a smooth way to create superior user experiences. One way to think about this is imperative could be a function of declarative. So Replit, the code editor, has a lot of automatic functionality where it detects the user intent and reconfigures the environment based on what you want to do. In this case, I'm asking ChatGPT for a Flask app that generates a random cat every time I go to a website. Very useful app. And when I copy this piece of code to Replit, it goes from this sort of editor in console or editor chat interface and reconfigures itself to render the server and render the output. And it installs the packages you need. You don't have to do anything. You just copy and paste, and it kind of does everything for you. So the environment is a function of the code. And we think that's a sort of a good framework for designers to think about. You issue a declarative command, some generation happens, some generative thing happens, and then the imperative thing or the UI gets reconfigured on the fly to fit that sort of declarative command. This is our debugger. This is another way to think about this relationship between declarative and imperative. We are coding in sort of this imperative way, but then the debugger appears and asks us if we want to engage it, and it's sort of, without us going and prompting it, it sort of detects that there's an error. We click on the help me debug, it tells us the answer, and we decide whether we want to act on the answer or not. So workflow is imperative, but sort of the declarative portion of it is sort of optional. In this case, I'm actually coding. I see an error using a classical tool. This is IntelliSense. It's kind of the squiggly lines. You were all used to these tools, even pre-LLMs. And this is a tool based on just parsing and seeing whether the code is actually accurate or not. And typically, those features are entirely separate from LLM features. But in this case, we hover over that sort of squiggly error, and it says there's an action there that says debug with a ghostwriter. And then that goes into the LLM, and the LLM kicks off and kind of gives us suggestions, or maybe even edits the codes on our behalf in order to generate the desired output. Another sort of big challenge for engineers and designers is there's a lot of ways to interact with these models. As we've seen, there's the inline suggestion use case. There's other sort of inline use cases. There's use cases where the model jumps in and tries to help you, sort of detects that it can be helpful. There are use cases where it's like purely chat and sort of generic, and you can ask any question in the world, and you expect the model to give you some reasonable answer. What we found is that for all these different use cases, you can use different models. I think people today, and the industry as a whole, is sort of focused on the next frontier AI model, such as GPT-4, rumored to be 1 trillion parameters. It's very expensive. It's very slow. But you won't be able to build an interactive feature with that. So I'm going to make the case today that you should learn about the different models, the different flavors, the different sizes, even as designers, in order to understand what kind of features and what kind of user experiences you want to build around them. The fundamental trade-off is fast versus general. GPT-4 is general. It can give you medical advice. It can give you legal advice. I suggest to double-check those advice. But it is slow. It takes a long time to generate these suggestions. Whereas something like the code model that we trained and we open sourced, if you want to build with that, it's called Replit code. It's a 3 billion parameter model. It takes less than 5 milliseconds to generate a token, whereas GPT-3 is 10x that. GPT-4 is probably 100x that. So it's orders of magnitude, takes orders of magnitude longer to generate an answer. And that is because Replit code was designed to work on the order of milliseconds, not tens or hundreds of milliseconds. And that is because it's narrow, it's domain specific. It needs to do one thing and one thing only, and it needs to be really good at that thing. Another thing that we sort of as a company start talking about is, we don't have a scientific word for it, so we just call it model vibes. And it's sort of the intuition that you build as you're working with these models. As you're building a feature with this model, you might swap out different models. You might use GPT-3, 3.5, you might use a chat feature, you might use a completion model, you might use Anthropic or Google, you might use an open source model from Hugging Face, you might train your own model, and then you build intuition for what the capabilities of these models. For example, in this case, actually our small 3B model is superior to generate React code than a larger model such as GPT 3.5. Santa is an even smaller model than our model. It's a 1B model, 1 billion parameter model. It's faster, but it generates generally crap that you don't need. And so there's a sort of a sweet spot in terms of size and capability that actually fits your use case. So it's going to take a lot of trial and error to figure out what model to use and what sort of capabilities you need. All right, so this was about designing with LLMs and kind of our experience building them. let's talk a little bit about what we're seeing around people building with AI. So we think like one of the main things. So there's a lot of talk about how Ghostwriter and Copilot and all these products make programmers more efficient, more effective. You hear numbers anywhere from 50%, some people say 10x, and it's true. I think a lot of people get a lot of productivity out of it. But one thing we're actually perhaps more interested in is that, again, this idea of making software creation more inclusive, and we think it gives people like you, designers, more agency over the software creation process. So this is the sort of cursed question that we all know about. But I'm not interested in that. I'm more interested in, should designer make software? That's a better question than should designers code. Code is a tool. It's a means to an end. It's not an end in itself. The actual end is the act of creating software. In a similar sort of question, should furniture designers be making furniture? Like, of course. And so any kind of designer is engaging in the act of making software. And we think that sort of tools like Replit and this AI revolution is going to empower designers to build software, in some cases end-to-end, without needing engineers. I'll give you a few examples. This is Saleh. He is an interaction designer, and he built this product called Notepad. And Notepad is a way of brainstorming with large language models. He built it entirely in Replit, and he deployed it. And it was one of the top stories in Hacker News for a while, and the product gone absolutely viral. Designer almost never built a product before, and this product was a huge hit. His first product was a huge hit because he's a software maker. Pietro is a designer at Bricks, and he actually, the moment GPT-4 came out, he was one of the first people to figure out how good GPT-4 was at coding. Think about that. A designer was the first to figure out the capabilities of a frontier AI model. Right? And I think that's really a crucial thing to think about. He was trending on Twitter when GPT-4 came out for multiple days in a row for the kind of explorations he was making. He showed that with ChatGPT and Replit, you can build a game in a few minutes. You can build an app in a few minutes. And he's been prolific since then. Every weekend, you see a new project that he's launching that goes absolutely viral. I don't know if he's here, but it would be great if he is. This is Priya. Priya was a PM at Microsoft. I think now she's interested in starting her own startup. But she won the Craft Ventures Hackathon. She won $10,000 by building a product on Replit. She actually built a product. I was a judge at that hackathon, and totally coincidentally, like half of the participants were using Replit and AI to create something. And the hackathon was structured in a way such as there's a non-technical track and there's a technical track, right? The technical track is the idea that engineers are more technical, and the non-technical track was PMs, designers, and so forth. Turns out that the non-technical track had more impressive projects than the technical track, more impressive technical projects. Priya's project was taking a doc and turning it into an interactive doc, calling into a lot of different generative APIs and generating sort of video, audio, and all sorts of interactivity out of just like a piece of text. Our North Star is that anyone can speak software into existence. We think that like software is one of these things that comes perhaps every few hundred years or 1,000 years or so in human history, and it changes the world. Previously we had the printing press revolution and literacy, and everyone in the world was able to kind of write things down and communicate with a lot of people. And with the internet, that brought it to kind of the masses where anyone can have a voice, and that created a more democratic world, and a world where anyone can have their voice heard. And we think that's a fundamentally good thing. Software is another such expression. It's a form of expression. It's a form of creative expression. And we think more and more people would want to engage with it. We set this arbitrary target that's like 1 billion software creators. But it can be more than that. We think that anyone at any given point in their lives might want to engage in the act of software creation. And ultimately, the point we want to get to is that you can pull up your phone, say what kind of software, what kind of action, what kind of thing you want to create in the world, and be able to talk to your phone and for Replit to generate it for you. So thank you, and happy to take a few questions.
Question, your mission or North Star around speaking software into existence, where does scale or growth fit into your mission versus creation? Or like, if someone creates software, is part of your product's mission to help them grow that software?
Yeah, absolutely. So we have a new product that we call deployments. And so like I said, Saleh, a designer, shipped his product, was on Hacker News, which is a highly trafficked site, and the project did not go down, and actually scaled to be able to do that. So you can, with a few clicks, you can scale your project up. We also want to help people monetize it. We want to help people advertise it. We have a large community of people that could be early users of your product. And so we really want to help you with the entire life cycle of creating software, and not just like making toys, but actually making a living potentially. Please.
So big fan of your tool. Replit is awesome.
Thank you.
Can you talk a little bit about the process of how you build new features in the IDE? Like how do specifically designers come into play, developers, PMs? Like how do you organize? Because it's a very technical tool. You are showing how you abstract it to non-technical users. So if you can talk a little bit of how that product development process works. That'd be great.
Yeah. It is sort of managed chaos. I don't know if we have a process. It's sort of like we do things and some things happen and sometimes we ship them. That's kind of the honest answer. But generally, like Replit has a sort of prototyping culture and a demo culture. We're actually like very inspired by early Apple design and engineering culture, where actually there wasn't a lot of silos between design and engineering, and anyone can sort of build a demo, and anyone can demo to me or anyone else at the company. So you see a lot of demos flying around, and ideas come from everywhere. And our designers, which are somewhere here, are responsible for a lot of the product innovation, because they also are able to be more empathetic with users more so than engineers. And I think that sort of structure where ideas can sort of emerge from anywhere, and like the best idea comes to the top, tends to result in a product that is more accessible.
Awesome. Thank you.
Thank you.
My name's Abby, but I just wanted to ask, since I'm starting a company right now and I don't know a lot about software, I just know very basic stuff. And so I was kind of wondering, like, my biggest fear, I guess, with stuff like AI projects that help with code is what if the code it creates isn't what I want and I don't necessarily know how to find that. So I kind of want to know a little more about what the limitations are and how it is we can, preemptively prepare for stuff like that.
Limitations of AI? Per se?
Yeah, like to help with code and stuff, like what might end up doing something you totally don't want it to do, and like how to make sure you're on the track that you want your code to be able to do.
Well, I think, part of the, core design concept of Replit is this iterative process. Mm-hmm. Something that designers are used to in tools such as Figma is that everything's visual, you're getting constant feedback. You draw a line, you see the line. Mm-hmm. Software has this indirection to it, where you write a line of code, and you have no idea whether it works or not. Yeah. So Replit, actually, its name comes from this idea of interactive programming. Yes. And so we want you to kind of do this loop where you generate code using the AI, you kind of put that code in, you run it, you get an error, the AI can help you kind of fix that error. If the code compiles and it runs, mm-hmm. it shows you the output. You can see the output, play with it. Okay. If you like it, you keep going. If not, you go back to the conversation with the AI, or you kind of change the code yourself. So I would say just like have that iterative sort of mindset, and also like don't have the AI generate like entire programs per se, just like more smaller chunks, and always be running the program.
Got you. Okay, thank you. I appreciate it.
Hi there.
Hey.
My name's Sean.
Hey, Sean.
And I'm a software designer with Blue Origin, the rocket ship company.
Awesome.
And one of the things that we have as a tenant is, there's a high, lofty North Star, which is, millions of people working and living in space, but for the benefit of Earth, right? So as you were talking, Replit as a facilitator for more code doesn't necessarily mean that the code that is created will be beneficial in the long run, So there's a design principle of cradle to grave, as they call it, right? So what we think about today in terms of a product may have some impacts that were unexpected and so on. It's a life cycle rather than just the creation part.
Yeah.
So where do you see Replit's place in that conversation of making products and allowing facilitation of products? Just because we can make something doesn't always mean that we should. Like, you could look at plastic when it first came out, it was a miracle, right? And now we have, the impacts of that. So with proliferation of software that anybody can make, there are potential unforeseen things that can happen. So where's your it's kind of an ethical question.
Yeah. No, I get it.
But where's your conversation in what the software does later?
Yeah, so I think the trade-off is between sort of a small group of people in Silicon Valley making the decisions for everyone in the world versus a more decentralized approach where everyone can make software. There's different trade-offs. Maybe the quality of software is more controllable when it's like a smaller group of people that are doing it versus in a sort of more distributed manner, you're going to get maybe bad actors every now and then. But net, we think it's better for the world that way. In terms of what we can do to kind of stop abuse and sort of bad behavior, it's something we invest in a lot. As a company, we actually, we're a company that provides free compute to everyone, so you can do really bad things with it. For example, you can launch attacks against other websites and hosts. You can crypto mine, you can do spam, you can do that. So a big part of our origin as a company was thinking about security and having that security mindset. And so we've been able to build our infrastructure in such a way that we're able to kind of shut down any potential bad behavior, and that's a continuing investment that we make.
Okay, awesome.
Thank you.
Love to talk to you about it more.
Absolutely. Yeah, thank you.